Today's lab, which is the last one, is about thermal expansion. What we're going to do is we're going to take 3 rods, ones of copper, aluminum, and brass, respectively, and heat them up and see how much longer they get. To do this, what I'm going to do really is we're going to measure the coefficient of thermal expansion. We're going to just see how much they should change for those types. What we're going to start with is at room temperature, and we're going to measure the distance between this little nubby here and this little nubby there, because we're going to get them stuck, and that's going to be our knot, our original length. I'm then going to take this and I'm going to put it in the setup like so. And what it is this side is locked into that piece, and this side is up against this foot, which can move. And the foot is attached to this dial. See, what that dial is going to do is it'll measure change in length. The dial reading is going to be what you want to get out of this. And with that dial reading, what we're going to see is exactly how much longer it got. Now, that is not going to be in a nice straightforward unit, but equation 2 can convert your dial reading to meters. I'm then going to take this, and I'm going to clip it on right in the middle. What that little piece of metal is it is called a thermistor. Sorry, I was about to call it something else, but yeah, thermistor. It's basically it's a resistor that measures temperature. I usually call it a thermocouple, but the name is in front of me and it messed me up. What it's going to do is that's going to become in thermal equilibrium with the copper rod. And what we're going to do is we're going to measure the resistance in the end. See, resistance is affected by temperature. We haven't covered that in this class. That's a physics 2 type topic. Just know that it does. But what it's going to do is it's going to output a resistance. For now, the resistance is 76.8 kiloohms, which probably means nothing to you. Honestly, it means nothing to me, other than the idea that it's probably really hot, because it's very hot in this room right now. What I'm going to do is I'm going to write down that value, 76.8 kiloohms, and I have a sheet that can convert from resistance to temperature. I would do that for you. 76.8, I'm doing it right now. I do not expect you to do that. Now that's 30.75 degrees Celsius, which is very hot. So that is the temperature of that right now at room temperature. I'm then going to go and I'm going to heat it up. And how I'm going to do that is I'm going to take some water and I'm going to put it in this guy right here. And actually I'm going to add a tiny bit more. There wasn't as much in there as I thought there was. Just off camera, what you're not seeing is me completely making a mess and dousing everything over there with water, because that's fun. So, I'm then going to go and put a top on this and take this tube and hook it up to the end. And I'm going to make sure that this is zeroed. And I'm going to turn on this guy. Now, this is a steam generator. It's going to do exactly as it sounds. It's going to get hot and make steam. And it's going to take the steam and shoot it through this tube. As the steam goes through the tube, heating it up. And as it heats up, we should get a change in length. Now, normally in lab, you would have to sit here and wait for this to happen. You are literally waiting for water to boil. But here's one of the first and only good things about doing it online. I'm going to jump cut to when it's done. So it is done now. So, if you look, my resistance is dropping quickly now, and this dial has moved. I didn't quite catch it moving. Wasn't quite quick enough. And you can see a little bit of water vapor shooting out the end of the pipe. See, what happened is this now is being filled with steam from my steam generator. That steam has heated the pipe. And because the pipe was heated, this dial went up. Now, as you can see, this has a reading of... That's right in the way of that thing. Just about 42 on this dial. That 42 will correspond to a length. That's how much it's stretched. Now, that was me just doing it for copper. So I'm just going to write down this resistance real fast. 42. We are then going to do the same thing by just swapping this out and looking at the other elements. As I said, this was copper. We also have brass, and here with brass we can see that once again everything's hooked up. I have my initial temperature and my zero, but here we go, it's already starting to go, and as the steam passes through we can watch this thing getting longer. as the dial moves. The dial is in a different position just because I had to re-zero it. And so we can see how much longer the brass got at 45 on the dial. And we can see that the resistance is dropping. The dropping resistance means an increase in temperature. Let that balance a second, and then as soon as that balances, I will write down those numbers, and we will switch to our last one, which is aluminum. And with the aluminum, we started at the same about temperature, and the steam generator is back on, and once again, we are going quickly. See if I can turn this a little more. And you can see it got a lot higher. This guy got all the way up to like 56.5. If I get a second to see if I can get 57. That it stretched a bit more. And we'll use all these values to find our various alphas. I'll be giving a good amount of the data. You can analyze it. That's the last lab. I apologize for these online format. This would be better to be doing in person, but this is the life we live in. I hope you enjoyed them. I'm really sorry about being online.